Video Game Bench is absolutely amazing. It says this is a research preview and it is designed to test different AI with real world video games to see how they perform. So the TLDR is they introduce a research preview of Video Game Bench, a benchmark which challenges vision language models to compete in real time of a suite of 20 different popular video games from both handheld and consoles and PC. They say they also introduced VideoGameBench-Lite, a subset of games where the environment pauses the game while the model is thinking, thereby ignoring the long inference latency bottleneck of modern vision language models. It says their benchmark focuses entirely on whether the VLM agents can beat these games in their entirety, given only raw visual frames from the game. In this research preview, they provide code explanations of our framework and initial observation of basic agent playing these games, which is pretty cool. So basically they're testing out to see how well these agents, these AI models actually do. And what's included into this is, well, GPT-4o, Claude 3.7, Sonnet, Gemini 2.5 Pro, and Gemini 2.0 Flash. As you see here, this is a simple selection of games from the video game bench that their video game agent is playing, which you see this like Kirby, there's some driving games, like some Pokemon, and they have a list down below, which I'll get into a little bit later on. They say basically large language models have shown to be capable of solving incredible difficult reasoning tasks such as math, coding, and other tasks, but I guess this is a different dimension for them where these things are trained on math, they're trained on coding, so it makes sense. So they're saying, what if we give them something totally new, which they've never seen before, which is, well, video games, and see how well they do on these. They acknowledge that they do well at those type of tasks like coding and math and maybe even writing. They said, on the other hand, while humans have completed video games, we have yet to see even the state-of-the-art LMs and VLMs complete games such as Doom or Pokemon. And so they said this led to the community to focus on simple or handwritten games. Solving real-world video games requires long-term and short-term reasoning, spatial understanding, and intuition. It said in the past, AI models for games were trained specifically on one game using an exponentially large exploration and or expert trajectory budget. VLMs are on an interesting alternative that can provide potentially solving multiple different types of games even without explicitly seeing them before. Listen to full video game bench. They also plan to provide a secret eval suite of games that agents can evaluate the performance. And so basically these games are relatively old, very classic games, but what they see is that these games aren't necessarily being finished by a lot of these games, and the list of games they have are on the MS-DOS and Game Boy, and they just feed in images. For the MS-DOS, they have 11 games, which is Doom, Doom 2, Quake, and Sid Civilization 1, Warcraft, Oregon Trail, XCOM UFO Defense, The Incredible Machine, Prince of Persia, The Need for Speed, and Age of Empires. For Game Boy, they have Pokemon Red, Pokemon Crystal, Legend of Zelda, Super Mario Land, Kirby's Dream Land, Mega Man, Donkey Kong Land 2, Castlevania Adventure, Scooby-Doo, and that's basically it. And they aren't really finishing these games. I think the most impressive feat they said they had was them getting to the mini boss of the first level for Kirby. They said the main issue here is the, well, latency between frames, where not latency between the game, but having the model think about stuff and then having to respond as the real world environment is changing. So if you think about maybe chess or whatever, when people play chess and they're getting beaten by these robots, when the robots are thinking about it, first off, they have specialized knowledge, right? So these AIs are trained specifically only to do games. Imagine if there's a person who only knows video games. That's all they do. They don't know how to speak, they don't know how to talk outside of how to understand the video game. That would be a monster in whatever game they freaking play. I'm pretty sure that their limbs and their fingers and everything will probably even malform or deform until whatever best position is best for to play that game. That's how serious that AI is if it was like a person, for example. And so since they have that specialized knowledge and it's only trying to focus on chess, that would mean that, well, it'll be really good at that, and the latency wouldn't be that much. As well as chess is a game where, let's say you played a game and then every time you made a decision, you blacked out for 3.5 seconds and then you came back, right? In any game you play, 3.5 seconds is pretty long, and you would probably lose that game because, well, that's too long for you to play, for you to be able to do anything about that. So the best thing to do is, well, have these games play on different types of games where that doesn't matter. Like in chess, if you close your eyes for 3.5 seconds and you opened your eyes, maybe your opponent moved their piece, but you can still take that into account, and then you can close your eyes again and then make another decision based on that latency. But if you think about it, if you don't have so many different thoughts to think about because you don't have different types of actions to go to, you can really just your latency would probably just be shorter because you don't have a whole bunch of informations and possibilities to go through because all you know is chess, right? So let's say it's probably half a second or a second. That's not bad at all. But when these AIs are trained on just generalized how to move, how to go left and right, giving images or inputs as the input, it makes it a lot harder for these AIs to actually perform. They did say that they did give AI the ability to pause when it's thinking to help out with the latency issue, but even once you unpause, the game is still going on, which is still an issue because even though you black out for 3.5 seconds, then you unpause, if you jump, like, how are you going to still interact with the ever-changing environment? So that's something there. They even have this clip where one of the AI agents was spazzing, where it confused the dead body of one of the soldiers in the Doom game to be, well, a person who's still alive, and they basically almost emptied the clip on the body because they thought it was still alive. These are still pretty good examples when it comes to these type of things, but they even have different issues when it comes to like World of Warcraft, where the AI got stuck in the screen trying to load the game because every time it tried to load a game, it kept on canceling it because it kept on not understanding how to actually get there. Instead of trying to make a new game, it was trying to have a load a game that it never loaded before. They never played the game, so it was a misinput every time, which just kept it in a loop. And then even with this Kirby game, it was an issue here because even though they was able to get to this level, they didn't understand the power system for Kirby, so that it absorbs the bomb and you were able to get the powers of the opponent. So end up just kept on losing. That's not even like the boss, that's just like the mini boss. So I know they're saying this is a benchmark to test out games, and I guess it would be interesting to see how well AI plays games, because we do have AI in video games, but they're kind of totally different. They're more like cheats. Because I swear when we play Call of Duty and you get those bots and you put them on the highest settings, they'll have wall hacks at that point. They have perfect aim, perfect shot. So I think this is a little bit different than that. But I do think, I'm not really sure how valuable this is as far as a benchmark, because this is a latency issue, it seems like, more than it is an AI issue. As well as if you just train an AI on any specific game, it will probably be exponentially better at that game once it's trained on it. And having it train on new game data would solve a lot of these problems. It can probably even predict each and every variable when it comes to how the enemy is going to move and how to respond to that, even with the latency, which is my theory. It is cool to see how they play with new games that they haven't been trained on, but wouldn't that only take them to be trained on it? So if you ever played a game for the first time with no gaming experience, go back to your OG gaming days and you think back of how trash you were at those games, and think about maybe how you are now or where you were in the future after you spent hours, days, and weeks on there. For the AI, it's kind of the same thing, because once you spend hours, days, and weeks on AI, it's basically training and learning every single possible outcome. And that's a cheat that we can't really have. We can't go from beginning chess player to in a month grandmaster just because we freaking watch gameplay footage of chess players playing and we watch it at 2x speed. AI is watching it at infinitely times speed and understanding it completely. It's just something that we can't beat when it comes to those type of things. And if it comes to real world, maybe PvP, player versus player, or player versus AI, maybe a little different. But at the same time, AI doesn't have vision problems, for example. So let's say you're playing a Call of Duty or a shooting game and you see somebody in the distance. Your AI could spot you, no issues. But if you have like a slight vision problem, or you need glasses, or you've been playing the game for a while, your eyes are tired, or you know what I'm saying, just your cognition is going down, AI wouldn't have that problem. AI would be like, oh, you're not a tree, you're not blending in. It can probably even do some type of depth perception with doing the analyzing how you're doing. As well as, man, AI could probably, even with being trained on some data, could even do some crazy stuff, but know your spawn points and spawn camp you. Also know how well to throw a grenade to hit a specific target for far away. So even expert level players in certain games, they know the spawn points, right? So it wouldn't be out of the question for AI to know your spawn points, as well as they may know how to shoot through buildings. It just seems like if you train this AI on these games, it'll just be a monster in my mind. But the real time effect of it is really the problem with the latency issue. But that doesn't mean like the AI is bad. And so I'm not sure how you take this evaluation or this benchmark and take it into the real world to be this AI is good or bad now, right? Because what is it? You know what I'm saying? That doesn't make it bad. Because if you took any human and you had it black out for 5 seconds while I played a game, I don't know how well it would do. I think that would be the real question. Take a human and give it the same kind of latency, but at the same time, you have to also find a game that this person hasn't played before. So I don't know. Tell me your thoughts down below. Tell me, do you think that this is cool, or do you think this is a cool benchmark but not really real world use for this benchmark? Either way, if you want to keep up with the latest and greatest AI news, quantum news, robotics news, you should definitely like and subscribe. With that being said, your boy Dex, not Dexter, out.